In this video, we will be talking about the differences between surface area, also known as total surface area, lateral area, and volume. When we're talking about these three right here, we will be dealing with three-dimensional objects and three-dimensional figures. So before I go over what the differences are and show you some examples, first I want to give you the definition for surface area. Surface area is the total area of the surface of a three-dimensional object. Notice how it says surface, meaning outside. So let's take this box here that's wrapped around wrapping paper. Let me undo this wrapping paper without ripping this wrapping paper. Notice how the wrapping paper is only on the outside for this box right here, and particularly this rectangular prism. This wrapping paper is known as the surface area for this rectangular prism. So to calculate the total surface area for this object, first I'm going to count the faces. 1, 2, 3, 4, 5, 6. So that means I will have to find the area for each face and then add them up to find the surface area. Or you could find the area of this wrapping paper, and it should be the same as to finding the individual area for this right here. Another example that I also like to say is painting. When you're painting the outside of your house, you're only painting the surface. Therefore, the paint is known as the surface area. Another example that one of my students gave me last year that I thought was a really good example was our skin. Our body is considered a third-dimensional object, and our skin is only on the outside. It's only on the surface of our body. Therefore, the skin is known as the surface area. So, I want you to pause this video for a minute and think about other examples that you could think of surface area. Next, we're going to be talking about lateral area. Lateral area is the area of a surface of a three-dimensional object, excluding the base and the top. Excluding again means not including, leaving it out. So taking this box here again. To find the total surface area, we said we had to consider all of the 6 faces. But to find the lateral area, first I have to identify the base and the top. Therefore, that leaves me with 4 faces. So that means I have to find the area of those 4 rectangles to find the lateral area. Another example that I like to give is showing my cup. This cup is in a cylinder figure. So first I need to identify the base, which is this circular base right here, and the top. So to find the lateral area, it is considered to only be this blue portion. Lastly, it will be volume. Volume is a measure of the amount of space occupied by an object. So how much is fitted inside of an object? So taking back to this box here, the volume will be how many spoons fit into this box. Or let me use another cup. This is again a cylinder object. How much water can fit inside? This water that I will be pouring into this cup is considered to be the volume for this object because it is inside of this cup. While again, lateral area is not including the base and the top, therefore it will be this white portion here. While the surface area will be this white plus the top and the bottom. So you need to find the area of these circles of the top and the bottom and the area of the white portion to find the surface area for this cylinder. Lastly, I want to talk about a sphere. A sphere is a very special 3D figure. A sphere does not have a lateral area because a sphere does not have a base or it does not have a top. The reason why it does not have a base or a top is because anywhere from the center to any point on the sphere is equidistant. Therefore, that is the radius. So there's no way to determine what the base is or what the top of the sphere is. So let's take a look. The sphere does, however, have surface area and it does have volume. The surface area, it's like the orange peel, while the orange is the volume.